So, as Joanna mentioned, I'll be talking about some of my work that tries to link brain and behavior in order to better understand social cognitive impairments that we see in schizophrenia. And just to start with an overview, I'll give a very brief introduction to schizophrenia and to social cognition in general, and then I'll spend some time talking about why social cognition is important for understanding schizophrenia and what we can gain by focusing on it as a research topic. And then I'll spend a good bit of time talking about the neural substrates that are thought to underlie social cognitive processing and social cognitive abilities, and how those might be abnormal in individuals with schizophrenia, and what this might tell us about impaired social cognition. And in doing so, I'm also going to talk a lot about links to specific symptoms with schizophrenia, and in particular paranoia, so we're going to spend a lot of time on that today. And then I'm also going to talk about linking these neural substrates to social functioning, so trying to make that link between brain and behavior. And then I'll end by talking about a couple of the studies that are more recent in my lab where we've started to focus on the specificity of social cognitive impairments in schizophrenia. And then I'll try to give you a couple of take-home points that we'll end on. So, as some of you probably know, schizophrenia is a severe mental illness. It affects about 1% of the population. It is a neurodevelopmental disorder. However, it's relatively unique in that the onset is relatively late. So we see it happening, or we see the formal onset occurring in the late teens all the way up to the early 30s. There is a little bit of a gender difference. It tends to affect females later than it affects males. But it's impacting people at a really important time, namely when they're transitioning into adulthood and independence. And so we see that it tends to have a very devastating effect on people's abilities to live independently, to achieve educational and life milestones like graduating from college, getting married, etc. It is a very heterogeneous disorder, but it's diagnosed based on a number of different symptoms and different combinations of symptoms, and these can be loosely categorized into two big sort of sections or categories. First, we have positive symptoms. These are things that are in excess of what would normally be experienced. So things like hallucinations, hearing voices, or seeing things that aren't actually there, or having delusions, so having beliefs that aren't true or that are unfounded. And then we also have negative symptoms, and this is kind of the flip side of the coin. So these are things that would be absent from a typical experience. So examples of negative symptoms are things like affective flattening, which is just having a very blunted or flat emotional expression, or apathy or avolition, which refers to the absence of goal-directed activity. And now, schizophrenia is also characterized by severe social impairment. And I've highlighted social dysfunction because this is really where my work focuses. And the reason I've decided to focus on social dysfunction is because when we ask patients, what are you not getting from your treatment? They identify social functioning as their number one unmet treatment need. They'll say, yes, my medications can help with my voices, they can help with this, they can help with that, but I would really like to have a job, or I would really like to have a relationship, or I would really like to have a better social network. And these are the things that right now our existing treatments aren't great at. And so what I want to do is try to figure out what factors might contribute to social dysfunction, so then we'll know what to target in interventions. And one broad area that seems to have a lot of promise for understanding social dysfunction is social cognition. And now different subdisciplines of psychology define social cognition differently. However, within schizophrenia, an NIMH workshop recently defined it as the mental operations underlying social interactions, including perceiving, interpreting, and generating responses to the intentions, dispositions, and behaviors of others. And that's a mouthful. That's a lot. But I do really like this definition because it links social cognition to social behavior. And it suggests that impairments in social cognition might lead to impairments in social behavior. And social cognition is also considered to be a multidimensional construct, and there has been some debate about what different domains go into this construct, but these are domains that were recently, I'll say validated, although I use that term loosely, that were generated from an expert survey and consensus process that I conducted with colleagues at the University of North Carolina and the University of Miami as part of a larger initiative to improve the measurement of social cognition. And we identified 4 things. So first we have emotion processing. This is very broad and very general, but at the most basic level, it includes things like recognizing emotion. At the more advanced levels, it includes managing and regulating emotions. So we can refer to it generally as perceiving and using emotions. Then we have social perception. This includes decoding and interpreting social cues. We also have theory of mind or mental state attribution. Some of you may know this as mentalizing. This is the ability to represent the mental states of others. So essentially to know what somebody else might be thinking, what they might be wanting. And then finally we have attributional style or bias, and this is how individuals explain the causes of social events in their lives. Okay, and so we've got a lot of different things that go into social cognition. Again, it's this broad construct, but the key here is that we think it relates to social impairment. Okay, and so one of the questions, now that we have some sort of idea about what social cognition is, well, why is this important for schizophrenia? And I've already stressed some of this, but first, we know that individuals with schizophrenia show impaired social cognitive abilities. And these are relatively large impairments. So meta-analyses show, for example, that for emotion recognition, the effect size for the differences between patients and controls is 0.91. For theory of mind, meta-analyses show effect sizes of 0.8 to 1.2, depending illness severity in the patients. And so these are fairly marked deficits or impairments that we see. We also know that social cognitive impairments are evident early, including the prodromal phase of the illness, which is before the person has the onset of their first official psychotic episode. So when they're starting to show some decline, but they haven't yet fully developed the illness. And we also know that they're stable over time. And this has been shown both cross-sectionally and longitudinally. We also see that social cognition is largely independent from general cognition, so things like attention and memory. And within the schizophrenia field, we call this neurocognition, which is kind of funny because all cognition involves the brain, so it's all neurocognition. But we do that to separate it from social cognition. And both correlational studies and factor analyses have demonstrated that these two things are separable and that there's a good deal of independence for each of them. And then finally, we know that social cognition does contribute to real-world outcomes. So I'm going to show an example from what is now an old study of mine, where we were interested in trying to test different predictors of social skill and to account for variance in social skill ability among patients. And so we looked at cognitive factors and social cognitive factors, and we used hierarchical regression. Doing so, we found that cognitive factors could account for about 15% of the variance that we saw in social skill among our patients. Now, when we added social cognition to the model, we were able to account for an additional 26% of the variance. And so what this tells us is that, yes, social cognition does account for variance in social skill, but it also accounts for variance that cannot be accounted for by your general cognitive abilities. Okay, so it's connected independently, but it also goes beyond some of our other well-known predictors. And as you can see, there's a lot of variance that remains unexplained. So there's a lot that we're not getting. But at the time, this was a pretty big advance because it was giving us another avenue to try for treatments. And I now feel very validated because the subsequent meta-analysis has shown that yes, social cognition does have a larger influence on outcomes than neurocognition. And we also see evidence that social cognition mediates the relationship between neurocognition and social outcomes. And so what this is telling us is that yes, social cognition can contribute independently, but also in this capacity as a mediator, which suggests that if we can improve social cognition, we might be able to improve functional outcomes. And I know I've said this over and over and over again. Now I'm finally going to tell you that yes, that is true. Right? So we know that treating social cognition leads to improvements in real-world outcomes, and this includes things like social adjustment, social relationships, reductions in aggressive incidences, improved social skill, etc. So we've got this nice body of work now showing that if we try to improve social cognition, we can actually see improvements in these real-world behaviors as well. And it's this strong link to function that has caused people like me to think about factors that might be contributing to the social cognitive impairments and to ask, well, what is really driving these impairments, or what might be happening at a more basic level that ends up resulting in these social cognitive impairments. And where I spent my time is looking at a potential neural basis. And so this figure shows some of the key neural regions thought to be implicated in social cognition, and it's not exhaustive by any means, but these are the main areas that have been investigated in schizophrenia. And I should also say that I'm going to talk about each one of these regions kind of piecemeal. I'm going to say this one does this and that one does that. But it's really important to remember that there are reciprocal connections between these regions. And so it's better to think of it as a network as opposed to discrete regions that do certain things. So I'm just going to start down here and then we'll go clockwise. So starting with the fusiform gyrus, this area has been linked to processing the static or non-changeable aspects of the face. So things related to recognizing identity. Next we have the posterior superior temporal sulcus. This area has been linked to detecting biological motion and also to processing the changeable aspects of the face. So things like emotional expressions, changing facial expressions, shifts in eye gaze, etc. And again, because the fusiform gyrus is involved in face processing, we also see it being linked to emotion recognition as well. Then we have the medial prefrontal cortex, which has been linked to theory of mind or mentalizing. Next, we have the ventrolateral prefrontal cortex, which has been related to modulating amygdala activity. And we're going to talk about the amygdala in just a minute, but also in this process of making evaluative judgments of social stimuli. I'm not sure what it is. I think
Are we streaming Richardson?
We are, that's what that
Okay.
is.
If Richardson can hear us, can you guys be quiet, please? You should be able to hear us.
It's the Lord, Noah.
Actually, no, it's not him. But he's a good suspect. So ventrolateral prefrontal cortex linked to making these evaluative social judgments. And then finally we have the amygdala. Those of you who have heard me speak probably remember me saying, this is my favorite region. And we're going to talk a lot about amygdala today. But it has been highly linked to emotion perception, the processing and detection of threat, and more generally just detecting things that are salient in the environment. And often social stimuli are salient, so we see this as being a very important region for social cognitive processing. And it's also been linked to complex social judgments. Okay, so now that we know a little bit about this network, one of the questions that we asked was, well, what do we know about these regions in individuals who have schizophrenia? And at the time that we first started thinking about this way back in the early 2000s, we had a few studies that showed that individuals with schizophrenia showed either reduced volume, like sort of brain volume in these regions, or they showed reduced activation. So this got us thinking, well, maybe these abnormalities might be in some important way related to impaired social cognition. And so we wanted to test this model, right? We wanted to actually bring people into the scanner, measure these regions, show them a social stimulus, measure these regions, and see what happened. And in testing this model, we thought that there were two important caveats. The first one is that, as I mentioned before, schizophrenia is a very heterogeneous disorder, right? And there are some symptoms that are more highly related to social cognition and to social outcome than others. And for us, paranoia seemed like a really important thing to consider and an important candidate. And here's why. So let's first just start by defining it. So paranoia can be defined as the belief that someone, some organization or force or power is trying to harm oneself in some way. Okay? So paranoia inherently involves a social other, right? It is a social symptom. You have to believe that someone else is intending to harm you. And we thought that this might be particularly relevant for activation within these brain regions. We also know that there are some important distinctions between paranoid and non-paranoid individuals with schizophrenia in terms of how they process social information. So we see biased attention and memory for threat-related material in paranoid individuals. We also see a personalizing bias, which is the tendency to blame someone else for something bad that happens to you, rather than the situation. So if someone doesn't call me back, it's because they don't like me and they didn't want to call me back. It's not that they were too busy to call me back or that something came up or whatever. We also see that paranoid individuals overestimate the likelihood of threats from others. And there were some very early intriguing studies showing that paranoid individuals actually showed reduced amygdala activation as compared to non-paranoid individuals with schizophrenia when processing threat. And so when we were thinking about testing our model, we said clearly we need to take paranoia into account, right? It seems like it could have important implications for how these brain regions work. The second caveat that we wanted to consider was specificity of this neural network. So as you guys know, schizophrenia is not the only disorder that involves social dysfunction. Autism, for example, is also characterized by severe social dysfunction. And we were curious, would we expect to see the same types of brain abnormality, or not, in individuals who show social impairment but who do not have a diagnosis of schizophrenia? So in the study that I'm going to share with you guys, we actually asked individuals with ASD and individuals with schizophrenia to come in, to hop into the scanner, to process some social stimuli, and to let us see what was going on. And so in this study, we had 48 individuals overall, which at the time was a large sample for an imaging study, now is small, particularly if you consider that we divided them evenly across 4 groups. So we had 12 healthy control individuals, 12 paranoid individuals with schizophrenia, 12 non-paranoid individuals with schizophrenia, and 12 individuals with an autism spectrum illness disorder. That didn't make sense. Illness diagnosis. And so we actually, first let me clarify that the paranoid and non-paranoid schizophrenia groups were not defined based on diagnostic subtype. Rather, they were defined based on their level of paranoia at the time that they came in for the study. So if they came in and they endorsed a clinically significant level of paranoid ideation, we put them in the paranoid group. If they did not, we put them in the non-paranoid group. So these are people who were actively paranoid at the time that they were scanned. And we asked them to do two different tasks for us. The first is the trustworthiness task, and you guys are going to hear a lot about this. I've used this in a lot of my different studies. Here, they just have to view 42 different faces. These are just grayscale images, and they just have to look at it and tell me if the person in the photograph is trustworthy or untrustworthy. So that's it. It's a dichotomous decision. And then we also had them do an age judgment task. And so they would look at these, at some different faces, and they had to tell us whether or not the person in the photograph was old or young. And at the time, you can tell I was young when I did this because I defined old as being over 30. If I were to do this, and I have subsequently done this study, I've changed that. Now I define old as being 35 or older, and I'm sure a couple years from now, I'll define it as 40 or over. So it's a moving target. But the idea here was to have two different tasks, one that required complex social judgments and one that required non-social judgments of social stimuli. And our goal was to look not only for specificity across disorders, but specificity of activation within this neural network for making more complex social judgments. Okay, so starting with some behavioral data, just to give some context. On the left here, you can see the number of faces that were rated as trustworthy by each group. We have controls, non-paranoid, paranoid patients, and then our ASD group. And as you would expect, our paranoid patients are rating fewer faces as trustworthy. Okay, that goes right along with paranoia. It's exactly what we expect to see. Now, when we look at the ratings of age, we don't see any differences between our groups. And this to us was very comforting because it suggested that, yes, our patients are able to make judgments of these faces that are consistent with what we see in healthy individuals, and they're doing our task, right? So they're in the scanner, they're not sleeping, they're actually doing it. That's what we want. Okay, and then if we look at group comparisons, I'll just direct you now to the top panel of this figure. This is showing areas where the control group is showing greater activation than the clinical groups. And what we see is that for both the ASD group and the paranoid schizophrenia group, controls are showing greater activation in the amygdala and in the ventrolateral prefrontal cortex, and the controls are showing greater activation in all three groups in the fusiform face area. Now, when we look at comparisons between our clinical groups, we see that the non-paranoid group is showing greater activation relative to both ASD and paranoid schizophrenia in the ventrolateral prefrontal cortex, and then relative to ASD in the amygdala. And so I'll try to summarize this a little bit. There's a lot to process there, but essentially what seems to be happening is that there's this separation between our groups, where we see that our controls and our non-paranoid patients are looking similar to each other, and our paranoid and our ASD groups are looking similar to one another. So we have sort of this hierarchy happening. And when we then look at the comparison between trust and age, we see that our control group did show greater activation throughout the social cognitive neural network when making those trustworthiness judgments, which is what we would expect given that they're more complex and require more social processing. And this happened in amygdala, ventrolateral prefrontal cortex, and SDS. And then, somewhat surprisingly, we also found the same pattern in our non-paranoid patients. It was limited to the ventrolateral prefrontal cortex, but this is relevant because we did not find any differential levels of activation in our paranoid or ASD groups. And so again, we see that separation, where our controls and non-paranoid patients are looking similar to one another, and our paranoid schizophrenia and ASD groups are looking similar. Okay, so what does this tell us? Well, first we have some initial evidence that neural abnormalities might subserve impairments in social cognitive processing. And so remember, our paranoid and our ASD group looked different from our controls and our non-paranoid patients in terms of their behavioral responses, and there were also the groups that were looking different in terms of their neural responses. We also see some evidence that neural abnormalities may be deficit-specific rather than disorder-specific, right? So we're seeing neural abnormalities in both schizophrenia and in autism. And this would suggest that for anyone who shows social cognitive impairments, with some variation of course, we might expect to see abnormal brain function. And then we also see that the social cognitive network in paranoid schizophrenia and ASD is not modulated by increasing social demands. So when they had to make those trustworthiness judgments, they didn't show any more activation than they did when they had to make those age judgments. And finally, paranoia may be important here. So I did not tell you guys this before, but I also asked everyone in the study to fill out a self-report measure of paranoid ideation, right? Here, higher scores indicate more paranoia, and you can see our groups again, controls in red, our non-paranoid patients, our paranoid patients, and then our ASD group. And what surprised me was that both our paranoid schizophrenia group and the ASD group scored almost identically on these measures. So both of them were endorsing significant levels of paranoid ideation, and we started thinking, well, that might be highly relevant to what we're seeing in terms of the patterns of brain activation. And I'm going to come back to this and talk about this more as we progress through. Okay, so this was a great start, and we were pretty excited about this, but there were some parts that we were unsatisfied with and some questions that we felt were made. And one of them has to do with this. We know from some earlier studies that healthy individuals show greater activation of this network when faces are rated as untrustworthy. So healthy controls are showing sensitivity to the level of threat posed by these faces. And so an obvious question for us was, well, does this pattern even occur in individuals with schizophrenia? And if it does it differ between paranoid and non-paranoid individuals with the disorder? So we had that as our first question. Then we also wanted to know, does this actually matter? Right? Is there any link to outcomes or to actual behavior? And so what we were able to do was a follow-up analysis where we looked at these questions and examined them specifically. And so our goals were to investigate whether neural responses in schizophrenia are modulated by trustworthiness ratings, that is how they judge the face, and how this modulation relates to social functioning. And we had three hypotheses. First, we thought that controls in non-paranoid patients would show greater activation when faces are rated as untrustworthy. So for control individuals, that should be the normative response, and we thought that the non-paranoid group would look more like controls based on the previous pattern of findings, right, where they were looking more like controls. We thought that the paranoid schizophrenia group would show less modulation in neural activity than the other two groups. Right, and here I'll say we did not also include the ASD group. This was a very targeted reanalysis, and so we didn't include them. And then finally, we hypothesized that greater modulation would be positively associated with better social functioning abilities. Okay, so here I'm going to walk you through the results. There's a lot to process here as well. On the left, you can just see our group difference in amygdala activation, showing greater activation for controls relative to the paranoid patients. So this is what we would expect based on the previous study. And here, I will also say that I'm using the amygdala as the example, but this pattern that we see is evident in all of the regions that we investigated, which for this study were everything that I showed in that first schematic of the brain, right? So we had 5 different regions that we were looking at, and we're seeing this same pattern in all of them. Now, what's interesting about this group difference is that when we break it down and we say, well, what was happening when they rated a face as trustworthy and what was happening when they rated a face as untrustworthy, we see that the groups actually don't differ when they rated the face to be trustworthy, and that's shown in the blue bars. Okay, so this is just showing mean % signal change extracted from amygdala. You can see that there our groups look similar. However, when we look at the orange bars, which shows the amount of activation that occurred when they rated a face to be untrustworthy, that's where we see our group difference. Okay? Both our controls and our non-paranoid patients show an increase in activation when they rate a face to be untrustworthy, but our paranoid group failed to do this. And that's what's really driving the group difference. Okay, so we're seeing a very specific type of abnormality here. And then, when we try to link it to function, we did find significant positive correlations between the amount of modulation that occurred and their ability to function socially. So we saw this positive correlation both in patients and in our healthy controls. And this was very exciting for us because it was the first time we had been able to make a connection, albeit a correlational one, between brain and behavior. Okay, so what are some implications from this? First, we know that reduced activation in paranoid schizophrenia is specific to the untrustworthy faces. Right? So when they're rating something to be non-threatening, they look just like our healthy individuals. Drawing on some previous research, we were also able to hypothesize that paranoia may involve disjunctions between autonomic arousal systems and neural response that result in the over-attribution of threat. So they're still viewing more of these faces, viewing and judging more of these faces to be untrustworthy, but that doesn't seem to be coming from the brain, so where could it be coming from? And based on some previous research, we might be able to hypothesize that it's coming from heightened arousal in individuals. And then finally, these results demonstrate a direct link between neural activation and social behavior. And this is something that was very encouraging for us and really made me think, okay, we need to do more studies like this, right, that will replicate this result. And so I'm going to just quickly show you another study where we again looked at the relation to function, but this time we focused specifically on amygdala activation during the recognition of threat-related emotional expressions. And so here we had 3 different facial expressions that we were looking at. We looked at anger, fear, and neutral. And we also manipulated the faces so that they either appeared to be looking directly at the person or slightly away. And in this way, we were able to manipulate the threat level of the stimuli, assuming that here the most threatening stimulus is the angry guy who's looking directly at you. Right? And he's pretty angry, so most people found him pretty threatening. And so we had 37 healthy controls, 35 individuals with schizophrenia. I was not able to parse these people according to Paranoia for this study, but we just looked at them as a whole. And their job was to get in the scanner, look at a bunch of these faces, and to tell me which emotion that face was showing. Okay. And so here, again, on the left, I'm just showing this basic group comparison between patients and controls, and we see greater activation in the amygdala for controls relative to patients, which is hopefully a theme now. We're hearing this a lot. And then when we looked at the percent signal change in amygdala in response to the most threatening face, that directed anger face, we did see a strong correlation between the amygdala response and their level of function. And this is just, in this graph now are just patients. Okay, so the controls aren't up here, but you can see it's a strong relationship, which again reinforces this idea that there's a link between brain and social cognition and behavior, and to me really suggested that maybe this is an area where we can start looking in terms of remediation strategies. We're working on behavioral things for social cognition, but maybe we can also do neural things for social cognition as well. Okay, now some of you might be thinking about this already, right? I've done all these studies, I'm showing all this stuff. Patients have reduced amygdala activation relative to controls, even paranoid patients. Now, this doesn't make sense, okay, and I'll tell you why. This is something that has vexed me for a very long time, right? If you guys will remember, is that the amygdala is linked to threat perception. I then talked about paranoia and insinuated that it is the over-attribution of threat, right? It's perceiving threat where none exists. So if we put those 2 things together, we should actually guess that paranoia should be linked to over-activation of the amygdala. And instead, I've stood up here time and time again and told you paranoid patients show reduced amygdala activation when perceiving something to be threatening, right? So this doesn't make sense. It's incredibly counterintuitive. And for a very long time, I banged my head against it and said, well, what is going on here? And then finally, I had a little bit of a light bulb. And I said, well, maybe part of what's happening is that it's how we're measuring neural activation. So right now, the typical imaging method uses something called bold contrast. It stands for blood oxygenation level contrast. What you do is you get an idea of what's going on in the brain when they're doing nothing, when they're at baseline, and you get an idea of what's going, or rather you get a measure of what's going on at baseline, and then you get a measurement of what's going on when they view a stimulus. And then you subtract them, and you say, now we have a change, and we measure that change, and we call that change activation. The problem, though, is that we assume all of our people are starting from the same baseline, right? And we don't know. We don't know that for sure because we cannot get a quantifiable baseline using bold imaging. But when I was on postdoc, I learned about a new type of imaging, some sort of new magical stuff that some physicists have come up with. And what it does is it actually allows for quantification of a baseline. It's called arterial spin labeling imaging, and it measures cerebral blood flow. This is a little bit beyond me, but I can tell you the basics of it. It uses magnetically labeled arterial blood water as an endogenous tracer, and from that it can then calculate a quantifiable baseline that can be compared across individuals. And so for the first time, we have the ability to actually see where are people starting. Okay, and so I wanted to test this in my paranoid and non-paranoid patients and see if they were starting from the same place. So I had 25 healthy controls, 16 non-paranoid people with schizophrenia, and 16 paranoid people with schizophrenia. And I asked them to do 2 things for me. First, we measured resting cerebral blood flow using pseudo-continuous arterial spin labeling imaging, and then we did our traditional trustworthiness task using bold imaging. Okay, so basically a replication of all the stuff that I've just shown you. And we're going to start with the blood flow data. And so when we did this, people were just in the scanner, they were lying still, they had their eyes open, they didn't have to do anything. We looked at blood flow within the amygdala, and when we extract those values and pull them out, we do see significant group differences in the theoretically expected direction, right? So we see that our paranoid group, which is shown in red, actually shows increased amygdala activation at rest, at baseline, they're doing nothing, and they're already showing this heightened level of activation relative to non-paranoid patients and healthy controls. And we did reach traditional levels of significance in left amygdala, not in right, although that pattern is still there. And then on the right, you can just see this in a voxel-wise analysis. Now, when we tried to replicate our previous findings with the trustworthiness test, we actually were successful. Right, so now we're asking them to come in great faces for trustworthiness, we're using bold imaging, and again, we're seeing reductions in amygdala activation for our paranoid patients relative to the other two groups, right? So we see these contrasting results, and putting them together, it suggests that perhaps the reason why we keep having all of these sort of counterintuitive results about amygdala activation in paranoia is because we're not considering where they're starting from at baseline. And my thinking is that these increased levels of baseline activation actually create a ceiling effect that make it harder to detect signal change with the bold method. And so what this suggests to me is that paranoia is probably not reduced activation of amygdala, but instead it's increased activation of amygdala that's probably there at the tonic level and kind of present all the time, and that might be why they're over-attributing threat to everything. And so this is important because there are pharmacological agents that can reduce amygdala activation. And so we need to, this is all correlational, we need to get in, we need to do some longitudinal studies and hopefully some experimental studies to be able to test this, but this is where we're now spending some of our time in the lab based on these findings. Okay, so I'm going to leave amygdala behind kind of just slightly and leave behind this issue of paranoia and transition to the issue of specificity. So at the beginning I said, in my lab now, we're continuing to ask about whether or not social cognitive impairments are really specific to social stimuli. And what about social stimuli make them uniquely related to social cognitive impairments? And so just to give a little bit of background, we know that individuals with schizophrenia show normal activation, normal levels of brain activation, when processing non-threatening stimuli. So when they judge a face to be trustworthy, they look just like everybody else. But we now have this link to threat. We say, okay, amygdala is linked to threat, but threat isn't always social, right? It doesn't always come in the form of a human. Instead, it can be either social or non-social. And so one of our questions was, well, do these brain abnormalities that we see when they're processing threatening social stimuli extend to threatening stimuli that are non-social, right? And so we're trying to get at this issue of specificity. And this is important given evidence for dissociations between social and non-social threat processing in schizophrenia, right? We have some evidence that individuals with schizophrenia show enhanced memory for threat-related material that's related or that's presented as words, but that they show a slowed response time for identifying angry faces. So they might actually be better at detecting threat when it's non-social, but then worse when it's social. And so we wanted to test this, and we've been exploring this using both imaging and behavioral paradigms. So first, I'm going to talk about our imaging study, and then I'll transition to the behavioral one. But here, what we wanted to do was examine the specificity of amygdala abnormalities in schizophrenia by dissociating social and non-social threat. We had two hypotheses. First, I thought that schizophrenia and healthy controls would show similar levels of amygdala activation in response to non-social threat, right? So it's not social, but it's still relevant to amygdala because it's threat. But I thought because it's not non-social, they might still be doing relatively well. And then I thought that schizophrenia would show reduced activation relative to healthy controls in response to social threat. So it's kind of this combination of like, if it's going to be threat, it has to be social in order for us to see amygdala abnormalities. So we had 22 healthy controls, 29 individuals with schizophrenia, and the groups were well matched in terms of demographic factors. And then I had an embarrassingly simple imaging paradigm. Okay, it was a block design. All they had to do was passively view images, but these images fell into one of four categories. We had our non-social threatening stimulus, which in this case were snakes. We had a threatening social stimulus, which were some really angry faces. And then we had a non-threatening social stimulus, our happy faces, the same individuals, we controlled for that. And then for our non-social, non-threat image, we had bunnies or rabbits. Why not? They're not threatening and they're not social, so there we go. And all individuals again had to do was just passively view these. There were actually 40 images within each block, and each block lasted for 25 seconds, and then they had a 25-second break in between. And so when we then looked at amygdala activation in response to these images, we found evidence for a three-way interaction between the level of threat either threatening or not, whether or not it was a social stimulus or not, and group. And I'll break this down and make it a little bit easier. So first, let's just focus on snakes and rabbits. The good news is, we're seeing the least amount of amygdala activation in rabbits, which is what we would expect, since they're neither social nor threatening. Now, relative to snakes, we're seeing, well, for snakes rather than we see this increase in activation, right? Snakes are threatening, so we expect that to happen. What's interesting to me about this is that we are not seeing group differences here, right? So our patients with schizophrenia are looking just like our healthy controls in terms of their response to snakes, and they're both showing increases relative to rabbits. So for processing our non-social stimuli, they're looking very similar. Now, when we look at how they're processing our social stimuli, then we start to see some interesting group differences, some of which aren't exactly what we would have predicted. But for happy faces, we see that our patients are actually showing reduced activation relative to healthy controls. And then for angry faces, we see that they're showing increased activation relative to healthy controls. And this isn't what we would have expected. However, if you can sort of think back to that image of the yellow and the blue bars that I showed for the trustworthiness, our non-paranoid group actually showed a heightened response relative to controls for the trustworthy stimuli as well as the untrustworthy stimuli. So this might actually be consistent with some of our previous work. But if we take a step back and we say, okay, so for our social stimuli, we're seeing differences between our groups. For our non-social stimuli that are still relevant to amygdala and that are still threatening, we're not seeing any group differences. Then this suggests the idea that yes, there is some specificity to what's going on here, right? So the impairments that we're seeing are specific to social stimuli. Okay, and now we've also done this with a behavioral paradigm. The goal here was to examine the specificity of social cognitive impairments by dissociating social and non-social threat detections, right? So here we still have emphasis on threat. This time we're looking at behavioral detection of threat as opposed to neural processing of threat. And the way that we did this was by capitalizing on something called the threat superiority effect. This has been well established in the visual search literature, and basically it's the idea that threat-related targets are detected more efficiently than non-threatening targets. And I'll show you guys examples of the task in just a minute, and I think it will clarify this. But we were able to have two different versions of a very similar visual search task that had one that was social and one that was non-social. And so we predicted that schizophrenia and healthy controls would both show a threat superiority effect on the non-social task, right? So they would both show this advantage for detecting threatening information when it was presented in a non-social format. However, we thought that only healthy controls would show a threat superiority effect on our social tasks. Okay, so let me show you what these tasks actually look like. First, I'll tell you we had 30 healthy controls and 35 individuals with schizophrenia. Again, our groups were well matched. And here are the two tasks we used. So they have quirky little names, right? We have our snake in the grass task, and then we have our face in the crowd task. And what happens here is that individuals are presented with groups of images. There are 9 images in each overall stimulus. And what you have to do is look at it and then determine as quickly as you can whether or not all of the images come from the same category or if there's an image from a different category somewhere in that matrix. And so in our non-social task, our categories are snakes, mushrooms, and flowers. And what's routinely found here is that people are faster to say there's something different here when that thing that's different is the snake, instead of when the thing that's different is a mushroom or a flower. In our social version, it's exactly the same, except that this time we use happy, angry, and neutral faces. And again, the finding is that people are much faster to say there's an angry person here, or to say that there's something different when that thing that's different is the angry person, than when that thing that's different is the happy person. Okay, so both of these examples show the threatening stimulus as the target, as the thing that's different. Here are different examples where we see a non-threatening target. So we see a mushroom in a group of snakes, and we see a happy face in a group of angry faces. And again, people will be much faster, whoops, let me go back, to respond, there's something different here, than they will here. So again, we wanted to give these tasks to our patients and our healthy individuals and see what happened. And so looking first just at our non-social task, we see that when the snake is the target, both healthy controls and individuals with schizophrenia respond more quickly, right? So they're showing the speed advantage and also an accuracy advantage for detecting the threatening stimulus. And so we would say that in this task, both groups are showing an intact threat superiority effect. Now, in contrast, when we look at our social task, we see that only the healthy controls are showing the threat superiority effect. Okay, so they are faster to respond when the angry face is the thing that's different relative to the happy face, but our folks with schizophrenia are not. Okay, and when we directly compare tasks, we do see a significant task interaction. Again, supporting this idea that there's some specificity to the impairments in social processing, right? So it's not all threat, it's social threat, and that there's something unique about the fact that it's social. Okay, so I know I've put a lot out there. The good news is we're finally to that point where I'm going to give you your summary to take home, and then open it up for questions. So I'm going to try to just boil it down to two main things that hopefully will summarize everything we've talked about today. First, we can say that social cognitive impairments represent a specific impairment that can help explain social dysfunction in schizophrenia. Okay, and this, I think, really reinforces the idea that, yes, this should be a viable treatment target. This is something that we should pay attention to. And if we do, we have the opportunity to potentially improve the lives of our patients. And then we can also say that abnormal activation of social cognitive neural networks may provide a foundation for impaired social cognition and social dysfunction. And granted, there is a long way between brain and behavior, right? And everything that I've shown is correlational. But I think this makes an argument for saying when we're thinking about social cognition, we need to think about both, right? And not just think that the only possible intervention strategy is behavioral, or that the only intervention strategy is maybe pharmacological or neural, but that we need to think about combinations of both, and that we need to be cognizant of both moving forward. So that is what we're up to in my lab. We continue to do studies along these lines. I would be happy to tell you guys more about anything that might be of interest, and thank you guys for listening. Oh, and I should very quickly acknowledge all of the people who helped with this. Woo, bad for me for forgetting it. But obviously a whole lot of people have been involved, and I should give a special recognition to Noah Sasson, who has been my collaborator across all of this in research and in life. So thank you guys for your attention. I'll be happy to answer any questions.